Saxon Algebra 2, Lesson 50. I'm so excited. I can't even tell you. Here we go. This is one of my favorite lessons ever. And you know, I do have quite a few favorites, but this is like top 5 for sure. Okay, completing this square is a technique, a process that we can use to solve quadratic equations. And I'll remind you of what quadratic equations look like. I'm going to show you the standard form. This is the boring part, but it actually makes sense after you do a little bit. Ax squared plus bx plus c equals 0. This is the standard form of a quadratic equation. Notice that there's an x squared, a plain x, and a no x term. We always write them in that order. They can have numbers in front of them. That's what we call the a, b, and the c. And they equal 0. What we do is we solve these by breaking them down in various different ways and then solving for x equals. And I'm going to give you an example of that just so you can see what I mean. Here's a specific quadratic equation. And I'm going to solve this by the one way we have learned so far. This one can be solved by inspection, we say. And you know how to do this. We look at it and we go, okay, what are two numbers that multiply to this and add to this? We don't see a number there, so I just squeeze in the 1. You can do that. And so I'm looking for two numbers that multiply to this and add to this. And I can see, oh, look, it would be 2 and 1, right? And it would have to be, we need it to be minus here, so one of these needs a minus, but we want it to be positive when we end up. So I think this should be the minus, and this should be the plus, all right? So then what we do is we change this into a pair of binomials, and we use this information to help us. So we have x plus 2. Remember, this is just an art project. We just take this and fill in. We always put the x's in the beginning. X minus 1, and we say it's equal to 0. And then we say, okay, if we're multiplying two things together to get 0, then either x plus 2 equals 0 or x minus 1 equals 0. And that tells us that x equals, and we can do the algebra in our heads, x equals minus 2 or 1, right? You know how to do this. We've been doing this. We call this solving it by inspection. Now, this method works out really well if the numbers fall into place and we don't have a numeric coefficient in the a place, right? The x squared has to be just there. We've done that all along. So solving by inspection works to a point. So that's the first one we've been learning, and it is, we call it by inspection. Different math teachers use different names for that. John doesn't really call it anything. I call it by inspection because we're just looking at it. All right, this only works for certain kinds of quadratic equations. What we're going to learn today is another kind that works for all, and it's called completing the square. And that is its joyous gift to the world is that it works for all kinds of quadratic equations. Solving by inspection only works for, honestly, it only works when the numbers come out to be cute little integers. So that's why completing the square is useful, good, and precious, I would go so far as to say, is because it's so much more useful to us in the long haul. So what I'm going to do is I'm going to show you how we complete the square. And then you'll have a heart attack. And then we'll complete the square again. We'll do a total of 3. And you'll go, okay, I think I can do it. It's a lot, I'm not going to lie. And when we talk about the other methods, because there are 5 total methods, you'll see that completing the square is not everybody's favorite because they developed it and then they were like, you know what, we can do better. So just keep in mind that this is not the end all and be all. This is just an important process along the way. So here we go. Completing the square. There are a lot of steps to this, and I'm going to write them on the side, so you're gonna have a lot of writing to do. Okay, so here's our quadratic equation. X squared plus 6x minus 4 equals 0. And we're supposed to solve it by completing the square. You can look and see if there's any way to solve it by inspection. And spoilers, every once in a while John throws one in. But most of the time, we'll see there's nothing that multiplies to 4 and adds to positive 6. It's not gonna work. So here's what are the steps. The first thing we do is we check for standard form. Remember, we want it to look like this. ax squared plus bx plus c equals 0, right? That's cool. And we're going to talk about this later, but if our a is any number than 1, we have to deal with it. But John's not going to give us that problem, that complication for a while yet. No, he's not going to throw us that curveball in this lesson, so don't worry about that yet. All right, so we look at ours and we go, yeah, actually that looks really good. John's got that in a great order for us, so now we move on to step 2. This sounds weird. Kick C to the curb. Mind the gap. What am I talking about? We're going to take this C term, right, the one at the end, and we're going to move it over. X squared plus 6x. Now, when we move it to the other side, it changes sign as it changes side, so it becomes positive 4. And this is what I mean by mind the gap. I want to leave a space there where the 4 used to be, or negative 4. I want to leave that space there because that's an important reminder for the next step, all right? So I didn't say swim it across the equal sign for a reason. I specifically call it kicking it to the curb. Next year you'll understand why, but for maybe it's even at the end of this year. But I say kicking it to the curb means sending it to the other side. Mind the gap means leave that space there. Now, 3. Fill the gap with a magic number. What? Magic numbers? Yes. Here's how we calculate our magic number. We take whatever number is in the B slot, right? So it's the number in front of the plain X. So in our case, it's a 6. I'll do it in a minute, just what we do. You take that number, you divide it by 2. You put parentheses around it, and you square it. What in the world? And then you also draw an arrow underneath for reasons I'll explain later. Comes up in another step. So this is the formula we use to calculate the magic number. Let's do it for ours. It would be 6 is in the B space, right? 6 divided by 2, parentheses squared, draw this, and now we simplify it. 6 over 2 is 3. 3 squared is 9. So our magic number is 9. When we find it, we add to both sides. All right, so what does that look like? Now we have, I wouldn't write it again, but I'm just trying to make this super clear for you. We fill in the gap plus 9, right? That's where the magic number goes. But to keep our equation in balance, we have to add it to the other side as well, right? So that's why I have to add it to both sides. I lost points in a math test in, I think, 8th grade because I added it to this side and I forgot that side. Let that be a lesson to you. Decades later, you'll remember your mistakes. I don't know. You might not be as weird as me about it, but that's my situation. Now, what we're going to do now, and I'm running out of space, so I'm going to explain it and then I'll flip. We're going to rewrite this. This is now a perfect square. The magic number turned this into a perfect square. And we're going to be able to write this as a pair of binomials times themselves, right? So that's going to be my next step. Let me flippy flippy. Okay, so what we have is x squared plus 6x plus 9, that was our magic number, equals 4 plus 9, that was our other magic number to balance it. So, and our magic number calculation was 6 over 2 squared, and I had the arrow there. This we decided was equal to 9, that's how I got the magic number. And I always write MN as like magic number calculation. That's how I write it in my notes so that anyone can see there's my magic number calculation. Now, this arrow is going to become important because when we go to write this side as a pair of matching binomials, because it is a perfect square, because that's what our magic number does for us, this is what goes in here. So I know that this is x plus 3 quantity times x plus 3. See how it's matching? Now we can check it just to be sure. These two numbers, as we know, should multiply to this and add to that. And they do. 3 times 3 is 9. 3 plus 3 is 6. So our magic number worked, and we did create a perfect square over here. Now, this is one way to write a perfect square, but the other way is like so. So what I want you to do is I want you to first write the perfect square like this, checking it using your magic number. The arrow that I showed you to point up, that will always be the number that goes in here. You can check it to make sure that it works. And then once you're sure this is good, collapse it into this style of notation where you write it as a square. Now, in the meantime, everything on the other side has just been waiting for us to add those two numbers together. It's fine. Okay, so we do that. So what this step was, this is 4. And what we do is we write the left side as a perfect square. And remember that we know what to put here because we take this. This could have a plus or a minus as well, right? This could, in some cases, it could be a -6, depending on what our original number was. We'll get one later. I'll show it to you. But I just want to remind you that your magic number in here, not the magic number, but this number inside can be negative. So pay attention to the sides. And then our last step is simply to solve. And if you notice, we have solved problems like this before. We've been practicing this style so that when you got to these problems, you would be like, oh, it's fine, I know how to do this. In order to get rid of this square, we want to take the square root of both sides. That cancels out because an exponent of 2 cancels out a square root of 2. So we just have x plus 3. Now over here, there's more drama. We've got a positive or a negative, and then square root of 13. That can't be simplified. 13 is prime. So our final step, the solving, is to just subtract the 3. So we get x equals -3 plus or minus the square root of 13. There, we're done. Wasn't that easy? Wasn't it fun? I know. You're throwing your shoe at your screen right now because you disagree with me. It's fine. You'll probably never come to love it, but I love it enough for both of us. Okay, we're going to do a couple more. We're going to do a total of 3. So there's 1 down, 2 to go. Now that we've written all these notes, and feel free to pause me if you need more time. Those notes are going to help you through these problems. You will not remember all those steps on your own. You won't for weeks, okay? That's my goal, is that you will, but I want you to practice doing these problems with these notes in front of you, All right. John does not write out his notes with as much. He doesn't write out his notes the way I do. Let's just leave it at that. And so looking in the solutions manual, it's going to be some help, but following these steps is my best advice to you. Okay, let's do another one. This one will go faster because we don't have to explain everything quite as much. Okay, I'm going to show you how John writes it in the book because he's a demon child. Well, technically that's utterly false, but you know what I mean. Solve this by completing the square. Step number 1 is to put the thing in proper order, and this is a hot mess. Well, it's not terrible. Oh my gosh, I'm having to eat my words constantly today, aren't I? Okay, so that's step 1. I can't resist giving you a little bit of reminder. Standard form. Step 2, kick to the curb. Mind the gap. So this is going to go over x squared plus 2x. I'm going to leave his empty space behind. His sign will change. Okay, 3 is magic number. Remember the formula is b divided by 2, quantity squared, draw an arrow at the b over 2. In this case, our b is 2. So it's 2, because that's b, over 2, draw the arrow, squared. 2 over 2 is 1. 1 squared is also 1. Okay? So no minus signs in here, because our b was a positive number. So we're still good on that. Okay, magic number, we add it to both sides to make a beautiful and stunning perfect square. Now we pay attention to this and make sure that it worked. This should be x plus 1. Let's make sure it works. 1 times 1 is 1. 1 plus 1 is 2. Okay, holla, that's good. So now we can write this folded up. I don't know why I always think of it that way. Equals 6, right? Okay. Now we're at the place where we, what did I call this step? Perfect square. Oh no, we did that already. The 5th step is to solve. Yes. And so to solve it, we take the square root of both sides. We get x plus 1 equals plus or minus square root of 6. Can we simplify that? 6 equals 2 times 3. No matching pigs in that pig house. So that stays as is. We always put the plus or minus, because when we're taking the square root, it could be a negative or a positive square root. We're going to subtract that 1 over, so we get x equals minus 1 plus or minus the square root of 6. How does it feel to get the right answer? Feels pretty good to me. All right, one more. Now, before we go on, I just want to say one more thing about this. The mathematicians, way back in the day, like in the, I think the 15 or 1600s, they were doing this kind of problem and they hated it. Too many steps, too much fussy detail. They came up with a workaround to avoid having to complete the square. So if you find this annoying and like way too complicated, the math geniuses of history agree with you. All right? So we'll get to that. We're learning this so that later we can not do it anymore. 50.3. This is the last one, I think. Let me double check. Yes. Ready? All right. John gives us x squared equals 5x minus 5. Ay, ay, ay. Okay, so now, step 1, put it in the right order. This is not okay, but we can fix it. X squared, this will become a minus. This will become a plus. We'll be left with a 0 over there. Okay, we got it in proper form. Now we're going to kick to the curb and mind the gap. Skip it equals minus 5. Now we're going to magic number it up. I always write this. It's minus 5, yes. We have a minus here this time. It's a different. Over 2 quantity squared. What is this unfortunate mess? Well, minus 5 squared is 25. 2 squared is 4. That is our magic number. Do you feel sad? I do. But it's going to work. Notice that when we square it, our minus sign goes away. But when we come back to that, that minus sign is going to be part of the number we need. And then we have to add 25 over 4. I can see I'm going to have to adjust this to give it a denominator of 4. So I'm leaving myself plenty of room over there. I'll get to that later, though. All right, so there's our magic number, business. I always want to see your magic number calculation. I'll tell you that right now. Now we want to write this as a perfect square. We know that it'll be x, and we know that this arrow points it to us. Minus 5 over 2. Can that be right? Yes, it can. So let's do it again. If they multiply, they should add to this. And if they add, they should go to that. Minus 5 times minus 5 is positive 25. 2 over 2 is 4. Okay, that works. Now let's add them. Minus 5 halves plus minus 5 halves. The denominators match, so it becomes minus 10 halves. Minus 10 over 2. And that reduces to minus 5. So both of these work out. I like to actually make the check marks there. I haven't been doing that, but I think that's really satisfying, and it reminds me that I checked. All right, so we can collapse this now. X minus 5 over 2 quantity squared. This is the form that we need in order to solve. So that's why I do this, so that I can check and look at it and make sure it's worked out. And then I collapse it down to this form. And now we're ready to add over here. This needs a 4 on the bottom. So we'll multiply it by 4 over 4. It'll become minus 20 over 4. I can combine those, and I get positive 5 over 4. Right? Minus 20 plus 25. Okay, great. Square root. Square root. Those cancel. X minus 5 over 2 equals plus or minus. Now let's simplify this as we go. The 5 is stuck. There's no pigs in there. It's going to be square root of 5. But this will simplify to a just plain 2, right? 4 is a perfect square. So this is going to be square root of 5 over 2. Simplify as much as you can as soon as you get this number pulled together, because it's going to be cleaner and better as soon as you do. All right, are you ready? Last step is to solve. We just need to add 5 halves. X equals 5 over 2. No, yes, that's right. Plus or minus the square root of 5 over 2. Some textbooks, some authors, some mathematicians will go ahead and squish those together and write it as a simple fraction. I don't like that. I like to see them separate for reasons I'll tell you about later. But keep your fractions separate when you write your answer, as I'll show you what I mean. That's the right answer. Don't do this. X equals 5 plus the square root of 5 all over 2. See how I shoved the fractions together? No. I wouldn't take off points if you gave me this on a test, but for reasons I'll explain later, it's very not preferable. That is a grammatically curious sentence. It's very not preferable. Interesting. Okay, guess what? We are done with lesson 50. If you are exhausted, I don't blame you. I think you need to go, I don't know, get some fresh air, go pet your dog and worry about the state of your life. I don't know. You'll figure it all out. It'll come together. And someday you will love this lesson as much as I do. I have no doubt. Okay, I do. I take it back. You probably won't ever love it. But I hope you enjoy it. And if you hate it as you're sitting there doing the homework, just think of what an utter nerd I am that I find those problems really fun. Okay, done. Goodbye.